sketch of a graph of a function help describe its behavior? Think about this question during the lesson. A scuba diver starts a dive with a full tank of oxygen. While diving, she breathes at a constant rate. She checks the gauge after 22 minutes. What does a graph of the function look like? Begin by identifying the two variables. The input variable is time, or T. The output variable is the oxygen level in the tank, or L. Now, we need to analyze the relationship between these two variables. Earlier, we saw the gauge change for the first 22 minutes. What happens to the oxygen level in her tank over time?
Select your answer.
The longer the diver swims, the less oxygen remains in the tank. The oxygen level in the tank decreases over time. Now, let's use the information we know to sketch and label a graph. We want a graph that shows the behavior of the function. Draw the two axes. Label the input variable, time, T, and the output variable, oxygen level, L. At 0 minutes, when the dive begins, the oxygen tank is full. Now, what happens during her dive? The oxygen decreases at a constant rate as time passes. You know that after 22 minutes, the oxygen tank is half full. Since the rate is constant, we can extend the line until the tank is empty. We know that as time keeps passing, the oxygen level will continue to decrease at the same constant rate of change. The sketch of the graph shows that the function has a negative slope, so the function is decreasing.
The weight of the water exerts pressure on a diver. At a depth of 10 feet, the water pressure is 19 1/10 pounds per square inch, psi, and at a depth of 14 feet, the water pressure is 20 9/10 psi. Complete the statements, then sketch the qualitative graph of this function.
The independent or x variable is blank. The dependent or y variable is blank. It says at a depth of 10 feet, the water pressure is 19 1/10. So the independent variable is the one that determines what happens to the dependent or y variable. So the depth, the water depth would be the x or independent variable, and there we go. And the dependent variable would be the water pressure, because that is what the time affects that. So that tells us that is the dependent. That changes based on what the independent variable is. So the dependent variable is the water pressure. Okay, so water pressure. There we go. So water pressure. So again, the independent or x variable is water depth. The dependent or y variable is the water pressure. So water depth will be here on the graph, and the water pressure will be here on the graph.
Danica sketched the relationship between altitude and time for one of her parasailing flights. Describe the behavior of the function in each interval.
So here is the graph, and Danica is being pulled higher into the air. Altitude is the height. So she's going up, and then it says Danica is parasailing at a constant altitude. So for this interval, she's at that same height or altitude, and then Danica is dropping down into the water. So now she's dropping, coming down, and then X line axis would be her hitting the water.
Jose is practicing javelin throws. What is the relationship between the height of the javelin and time? What would the graph of the function look like? The first step is to identify the two variables in the relationship. The independent variable is time, which we'll represent with the letter T. The dependent variable is the height of the javelin, which we'll represent with the letter H. The second step is to analyze the relationship between time and height, the two variables. When Jose first throws the javelin, it increases in height. After it reaches its highest point, its height decreases until it hits the ground. Now we're ready to sketch the graph. Label the axes of the graph H for height and T for time. The shape of the graph is the same as the path of the javelin. This point represents the height of the javelin when Jose begins the throw. This point represents the maximum height of the javelin. This part of the line shows the height of the javelin as it drops to the ground.
Haru rides his bike from home for 30 minutes at a fast pace. He stops to rest for 20 minutes and then continues in the same direction at a slower pace for 30 more minutes. Sketch a graph of the relationship of Haru's distance from home over time.
So they set up the graph for us already. We have a distance as our y and time as our x, and that's the minutes, distances in miles. All right, so without numbers, again, this is just a sketch. The first line says he rides his bike from home. So he's coming from home. We're going to start at what we would be as 0 right here in the corner. And it says for 30 minutes at a fast pace. So then it says he stops for and rests for 20 minutes. So we should be going up really fast. So it'll be a high line using less time. So that's why my line is going more like this instead of like that, because it says really fast. So we would need to go more straight up than to the right. So anyway, he goes fast at 30 and then he rests. So when you're resting, you're not moving. So then he's straight or consistent or at that one time span, he's not moving. Then continues in the same direction at a slower pace for 30 more minutes. So now same amount of time, but he's moving slower. So the time should be lower. So now my line isn't as sharp as far as going up as it was the first time because it's moving slower, but it's the same amount of time. So this is essentially what it will look like. And again, this is a sketch.